All right, welcome back. Welcome back. This is part 18 of finding zeros of functions. And actually, this is part 2 of the last video part 16, where we started to use the quadratic formula in order to simplify and find our zeros. And so, in continuing on, I wanted to show you x equals plus 1, that's a positive 1, plus and minus 7 divided by 2. And so we want to focus on this plus and minus. Outside of every radical is a plus and a minus, right? So what does that mean? That means 1 plus 7 divided by 2. And that also means 1 minus 7 divided by 2, right? 1 plus 7 divided by 2, or 1 minus 7 divided by 2. Let's take a look. I'm also going to show you why, when you use the quadratic equation, your answers end up as zero forms, as a zero form. Kind of goes back to how we started, with the standard form being equal to 0. That's kind of how we started it. So again, 1 plus and minus 7 divided by 2 is 1 plus 7 divided by 2, or 1 minus 7 divided by 2. And there's a reason I use this simple equation equal to 0 at the beginning, so I can show you why these answers are the way they are. So as we continue, using order of operations, we add and or subtract. So 1 plus 7 is 8 divided by 2, or 8 over 2. 1 minus 7 over 2 is a negative 6 over 2. Now to simplify these fractions, I'm going to show you here. We have every fraction's a division problem. If you haven't seen my fraction videos, go please help yourself, check those out. Every fraction is a division problem. So 8 divided by 2 is 4. Negative 6 divided by 2 is a negative 3. So because at the very beginning of the start of this part 1 video, that was part 17 of the entire series, we started with an equation that equaled 0. So our factoring terms that we came up with here, 4 and negative 3, are the zeros of the function or equation, okay? Because it was already in equal 0 form, all right? If you need to go back and look at part 17 in order to see that, that's fine. But I'm going to show you here the original problem, again, and why our answers for this problem, the zeros are 4 and negative 3. Okay, so if you look at the original problem, remember it was x squared plus negative x minus 12. Now these were color coordinated, right? The negative 12 was green, the negative invisible 1 was blue, and then the 1 in front of that x squared invisible 1 was red. We substituted them into the formula. And if you remember, we set them equal to 0. It has to be an equal 0 form in order for us to substitute these values into the quadratic formula. And if it's not in this form equal to 0, then you're going to come out with the wrong answers for your factoring, right? It has to be in the equal 0 form. So now I'm going to use factoring using reverse FOIL. Remember, that's the two parentheses, right? Where x times x is x squared, right? Two numbers that multiply to a negative 12, but then they add up to that negative 1 value here in the middle. Well, I'm going to set up my factor tree. What are all the numbers that multiply to a negative 12? I'm showing you them here. Negative 1 times 12, 12 times a negative 1, negative 2 times 6, 2 times negative 6, negative 3 times 4, and 3 times a negative 4. Well, which of these factors would add up to that negative 1 in the middle? Well, positive 3 times a negative 4. That gives me negative 12. And then 3 plus a negative 4 gives me a negative 1 in the middle. So I can put these terms inside the radical. X plus 3, x minus 4. Because when we multiply x times x, that gives us x squared. X times a negative 4, 3 times an x gives us that negative x value in the middle when you combine like terms. And then 3 times a negative 4 gives us negative 12. So since, again, these are equal to 0, I can take each of these terms and set them equal to 0. So I'm going to move this up just a little bit. Hopefully that hasn't confused anybody. I like to leave my answers up on the top for my zeros of the function. And another quick tip before we get any further is you can see in the original problem, I have x to the power of 2. That means there's going to be 2 answers, 2 zeros for the function, right? If this was x to the third power, there would be 3 values of 0 for the function, right? If this was x to the fourth power, there would be 4 zeros of the function, right? But here there are 2, so only 2 zeros are the answer for this particular function or problem. All right, so I'm going to set each of these equal to 0, so x plus 3 equals 0. X minus 4 equals 0. I'm showing you that here. Now I'm going to solve for x. What's the opposite of adding 3? Or what number plus 3 gives me 0? Well, that's a negative 3. So I subtract 3 to both sides. X equals 0 plus a negative 3 is negative 3. Or, right, what is the opposite of a negative 4? It's a positive 4 to both sides. A negative 4, positive 4 it cancels out to be 0. I'm left with x all by itself on the left side of the equal sign. 4 plus 0 is 4. X equals 4. Another way to look at this is what number substituted for x plus a negative 4 would give me 0. Well, that would be a positive 4. It's another way to look at it here. So you can see my zeros are negative 3 for this function and positive 4 for this function. Hopefully this has made things a little easier for you. I've got a second example on how to use this quadratic formula in order to factor and find your zeros. Thank you for joining me. Hey, math is easy. Take it step by step. If I've helped you, can you please help me continue to bring these videos to you? You can donate a star or gifts. Thank you.